Hello guys, I know some of you thought that my next video was going to be about chemistry or chemistry proof. Now I've got a lot of videos that I'm planning to do. I've got one physics proof that I'm going to do soon, I've got one chemistry proof to do, and I've also got to do a video discussing a pseudoscientific nature of homeopathy, and I will come to those. But I'm doing this video because I recently looked at Cryosphere Today, which is a kind of Arctic sea ice blog that I'm following, and I was astounded at how badly the Arctic ice seems to be doing. I mean, this year, it's at the moment we're going for another record low. I mean, even lower than 2007. There's a small possibility the Arctic ice could be gone in a couple of years. So I thought, since it's at the moment very critical, because it's late July and the Arctic ice won't start recovering until September, and it's already past the lowest it should be for September. So it's really rather worrying. So I thought I'd do a quick video on the Arctic sea ice. So okay, so I've taken these images from one of the satellites that's used to monitor Arctic ice thickness. This one's the AMSR satellite. What we've got on the left is Arctic sea ice concentration. The percentages aren't too relevant because most of the ice has nearly 100% concentration. Concentration is basically in, say for example, a square mile. It's the percent of sea ice that's actually ice. So in any square mile there'll be small meltwater pools and that kind of thing. So a lower percentage ice concentration indicates that the ice is partially melted. For example, it has no relation to thickness. That's important to differentiate between. This is not sea ice thickness. But most of the Arctic sea ice has got a thickness, has got a concentration of more than 90%. Apart from the ice that's north of Alaska, you can see here that this has got an unusually low sea ice concentration. So I'm thinking that over the next couple of weeks, this will be the next batch of ice to go. So we could see a sharp drop in Arctic sea ice thickness over the next few weeks, courtesy of this part of the sea ice breaking up. So that's something to watch out for. On the right, I've got a graph of my sea ice extent. It's not as important as volume, but it's interesting. You see that 2007 was the last record low, and that was highlighted in the media quite a lot. But we're actually below this, and there's a definite possibility that this year could be worse than 2007. So that's something to go on. Personally, I think it's going to be a close call, and I think the Arctic ice could, at the last moment, show some kind of recovery and move away from being the all-time record low. Like for example, after 2007, people thought that 2008 was going to be a worse year, but it wasn't. So it's not always completely predictable, it's kind of a fickle thing. So I won't be surprised if it starts to level off, but equally I won't be surprised if we see a massive drop and we have some kind of record low. So what evidence do I have to make these sorts of claims about the Arctic sea ice thickness? Well, I'm going to look at these images here. These are from a German website, and the GFS model outputs, which is basically observations that use to model weather, things like air pressure and temperature, wind velocity, that sort of thing. And this is from a global forecasting system which models the entire Earth. And the pictures on the left are analysis pictures, which is what the GFS model thinks that the weather's like at the moment. Although it's important to distinguish that these are not observed conditions. These are conditions that the model happens to think that, based on previous observations, that it's most likely to be like around now. So they're not 100% accurate. And the model on the right is kind of like and what I meant was the ones on the top are analysis, and the ones on the bottom are projected. So on the left we have 2 meter temperature. So this is the temperature of the air at 2 meters ASL above sea level. So on the analysis, which is around about now, the sea ice temperature is actually around about normal. At this time of year, you wouldn't expect the temperature of the Arctic sea ice to be much below zero. and Greenland's the exception. You might notice that that's particularly cold, but Greenland's a landmass, so that's an exception to the rule. But in the Arctic basin, the temperature's around about normal. Although, having said that, in the last few weeks it's been highly above normal, so that's why we've had a lot of melting in recent weeks. Some very dramatic melting, but at the moment it's actually okay, and the GFS is actually predicting it to be okay in the future as well. And we've actually got some slightly below average temperatures forecasted. Although despite this, we've got some regional anomalies I want to point out. Most notably in the Northwest Passage, it's particularly warm, so that can endanger some of the ice that's been blocked. So I've shown here that this is the Northwest Passage, and you'll see that it's completely choked with ice at the moment. So that could threaten the potential for some for the ice to remain steady there. And we could see yet another year where both northern route, which is this route, and the Northwest Passage, which is here, and being open at the same time. And this has only happened once before. I think it was in 2008, although I might be wrong about that. It was either 2008 or 2006, one of those 2 years. Anyway, the images on the right are predicted pressure patterns, slipped, which is basically the predicted pressure at surface level. And this is particularly important in modelling how the Arctic sea ice melts in the Arctic. What in perfect conditions is a slightly slack field of low pressure to be over the Arctic basin, particularly towards the north of Greenland. Low pressure causes cloud cover and snow, but you don't want storms over the Arctic, because storms tend to produce things like gales and wind, and that tends to break up the ice more than it stops it. So at this time of year, you want kind of like cloudy conditions, which produces the coldest kind of weather. You don't want high pressure. And at the moment, pressure is not particularly high over the Arctic. Although, having said that, pressure is lowest in the Kara Sea, which is actually not particularly good. We want the pressure to be lowest north of Greenland, so that ice isn't draining out of the Arctic basin. It also means that the coldest conditions being over the Kara Sea is not particularly helpful, since most of the Kara Sea is ice free anyway. So it's not particularly helpful that the coldest conditions are there, and we want the colder conditions to be near the north of Greenland and the central Arctic basin near the North Pole. And actually, the projected conditions are actually even worse, because we've got a ridge of high pressure forming here, and again we've got potential some low pressure over the Kara Sea north of Siberia, north of Russia, which is a continuation of. It's not as extreme as we've had it in recent weeks, but it's a continuation of some pretty annoying anomalies which indicate increased ice melt in the Arctic. It's a particular dipole that we don't want. It's the worst possible scenario. Of course, it's not as extreme as it was in recent weeks. The other thing that's important to look at, as well as predicted conditions, to ascertain whether or not the Arctic ice is going to be a record, is also have a look at some other parameters. So what I've got here is I've got snow cover and ice thickness. These images are taken from two different models, and like the GFS, which models things like pressure and temperature, these actually model the ice, and they're relatively recent, especially the one on the left, which is the topaz output. So the Arctic ice thickness, it's not observed, so you have to take it with a pinch of salt. It's not going to be 100% accurate. First thing I'd like to point out is that the snow cover over recent months has dramatically decreased. The snow cover is incredibly important because it affects the sun's light and protects the ice underneath from melting. And as you can see, virtually all the snow cover is gone. The red indicates a snow cover of only 5 centimeters. So there's virtually no snow cover left. A dusting at the most, and it's probably slushy deposits. There's probably in fact, this probably overestimates it. There's probably virtually no snow at all over the Arctic basin at the moment. Settled snow, that is, anyway. So that's a bit of a problem. It's also incredibly early for this sort of thing to happen. You'd expect the snow to have completely melted in the summer. You'd expect that, but you wouldn't expect it to happen this early. As I say, the minimum is in September. Also, it's interesting to note that this year there's been particularly low snow cover over the Eurasian continent, and this generally has made things worse, because snow cover over the continent absorbs sunlight. Without the snow cover, the continent warms up, and some of the heat moves from the coast onto the ocean. I mean, that's probably one of the reasons why this kind of area north of Russia has had so much melting. I mean, another reason is because the melt season started so early. We had some kind of early melt season, so Arctic ice that was at higher latitudes melted quicker, which meant that there was again, because obviously open water absorbs most sunlight, whereas ice reflects a lot of it. So even ice that we know that's going to melt anyway, for example over the Hudson Bay, is still useful to have because it does reflect some of the heat and prevent the heat transfer to the Arctic itself. So that's one reason that the Arctic's melted so badly. But here's the first piece of encouraging news. The ice thickness is actually not too bad. You might notice that actually that these two models, there's quite a large disparity between them. This scale indicates there's only a thin sliver of ice, well actually about the largest sliver of ice that has a thickness of more than 2 meters, whereas this model suggests the vast majority of the Arctic basin is thicker than 2 meters. What I would say is that I'm not entirely sure which model is more accurate because I haven't had that much experience with them. Although I would say that the distribution of ice thickness on the pips is probably better to go along with than this one because the pips have been around for longer. But I would say that the thicknesses on the pips, which is this model here, are probably overrated. So I would tend to think that the actual values, the numerical values, are more accurate on the topaz, but the distribution on this is pretty well done. I seem to find. I mean, for example, one feature I'll point out is this hole in this seemingly thin part of ice near the North Pole, and I have observed on GFS models that there has been a warm anomaly here. As a result of perhaps a centre of an anticyclone or something of that nature. So the distribution is done quite well, and of course the thickest ice, as shown in both models, is always to the north of Greenland, because there's not as much flow away from here. Which brings me to this particular parameter, the ice flow. And the vast majority, most of the Arctic ice is drained down the east coast of Greenland. That's the biggest loss of ice, and actually, compared to recent weeks, again this is actually quite good, and not as much ice is draining as I would expect, and some of the ice is actually moving towards the north coast of Greenland, which is again quite good, because if we get the ice piling up it gets thicker, so it can survive more melting. As long as there's not that much ice draining down the East Greenland coast, that's always a good thing. So I'm not particularly concerned with the ice flow at the moment, but ice flow is also determined by weather-like pressure patterns, that sort of thing. So we want to watch in coming weeks. So based on this data, what's my predictions? The northern route is virtually already open, as I showed you here. There's only tiny bits of ice remaining on the coast of Siberia. You can actually see on perhaps the topaz model better. There's a large chunk of ice here, although I'm sure that's overestimated. Anyway, I think the northern route is I'm pretty much guaranteed that that's going to open this year. But the ice apart from that normally tends to be very, very thin, and ice tends to be moving away from this kind of area, and it's already suffered the biggest melt anyway. That's where the ice started to melt the most. So and ice started to melt in that kind of area a full month earlier than it should open. So I'm pretty certain the northern route's going to be open, and probably it will open the next week or so. So yeah. Will this be a record year like 2007? I think 50-50. I still think there's a potential for it to come back because temperatures are not too high, pressure patterns are not too extreme, although they could be better, and the thickness is still quite good. So I still think that the sea ice extent could still come back from this. I don't think the Northwest Passage will open because it's completely choked with ice, and in previous years it's actually been a lot worse off than this, and there's no real evidence of significant melting in the Northwest Passage. I don't think that will open. Although there was that hole indicated on the PIX model, I don't think there's any real probability that the North Pole is going to be completely ice-free. Even though the ice is drifting towards the north coast of Greenland, I think there's still quite a high amount of ice near the North Pole, and I think it's highly unlikely that the sea ice will be free this year. But still, 1 in 20 probability is still quite high,